Hello everyone and welcome back. In the last video we talked about how we used some rainfall information from the terrain generation algorithm in order to specify different colors for the very same tiles. And one big step that we went through was to actually use sprites in order to paint the tiles instead of just painting the very same color everywhere. And I probably mentioned that since it was an image, we could paint whatever we wanted, but back then we just had a single color for every different type of tile. Well, now it's no longer true. Let me show you actually the sprite that we use. It's a single file, a pink file here, that looks like that. What you see in white is actually transparent. So for example, in this square of 50 pixels by 50 pixels, you have the tile for water, then you have plains, hills, mountains, and the same for vegetation. And then you have more tiles to be able to paint things like farms, residences, skyscrapers, and so on. One thing that you may notice here, by the way, is another thing that I added, which is the use of WebSockets. Every time we move somebody, or we build something, or we do whatever we want in the game, we send data through the WebSocket. And every time somebody else does something, we receive the data about what they did in that WebSocket. So for example, if I move this guy over there, it's sent immediately through the WebSocket. And if somebody else does something, it gets updated on my screen because I receive it. Now, talking about moving people, something else that I did is implement the A-star algorithm. Now, funnily enough, in order to show the tiles that I can go to inside of this white line here, I needed to use the distra algorithm. But in order to show the shorter path that I can take in order to go somewhere, I actually needed the A-star algorithm. Now, if you know the A-star algorithm, you'll know that I need a heuristic, a way to roughly know how far something is without knowing the precise number. And it turns out, because again of the coordinate system that I use, which is basically 3D cubes, I can use the 3D distance in order to specify a rough distance from where I am to where I want to go. And it works pretty well. Obviously, I have to do some hacks, for example, in order to avoid crossing water when I don't have a boat and things like that. But overall, it's pretty simple, slick, and it works, which is really the main purpose here. One last thing that I did is to be able to build stuff, and I had to build a UI for that. Those buttons must have seemed pretty strange so far, but now they have a purpose. This one is to be able to travel somewhere. This is to be able to split our group. So for example, we are 3 here. We can split it in 2 on one side and 1 on the other side. And on this panel here, we can actually create stuff. For example, a farm here. And there it is. Now you may have already noticed that I made the map draggable. Now it's slightly easy to do in Chrome, but it's a lot harder to do in Firefox, for a number of reasons. The first of the reasons is that Firefox, especially on Linux, has a very slow implementation of get image data and put image data. Both of them are really slow. So we have to limit as much as we can the use of those APIs, and that's what I ended up doing. But I'd like to talk about all the things I did. In all of the approaches that I took, I ended up focusing on one very specific approach in order to make drag and drop fast, and that is to save the bitmap data for tiles on the map and show them every time we want to have something on top of it. So all the buildings and all that is actually drawn on top of a tile that is unique for this area, and then here we go to the next tile, and then there is a next tile up there, and so on. Obviously we don't see them, but I know by habit that this, for example, is the top left pixel of one tile which is rectangular and which goes all the way to around here, something there, and then this is the next tile that is drawn, and so on. The problem is, how do you source those rectangles of pixels? So let me present the code very quickly. This paint tiles from cache is a way to protect the very expensive method which is called paint tiles, which is right here, and that method is expensive because it has to call the terrain generation algorithm. You don't want to do that every time you paint the pixels on the screen. So that's why we use the cache with the rectangles containing all those pixels. Now, how do you store those pixels? Well, the obvious way is to use getImageData and putImageData. So when you start caching the file, you use this right down there. You paint all the stuff on a buffer canvas context, and then you save the image data corresponding to that context in a cache, which you store in a map. But the thing is, getting the image data is slow, especially in Firefox. So even in Chrome, when we arrive to a boundary corresponding to a tile for a cache that we did not have yet, it took a bit of time to get the data for that rectangle, and then it could show it, and that caused some lag on the edges of the rectangles, and that was even more costly in Firefox and really painful. Firefox is known actually for being very slow with getImageData because of a bug, especially in Linux, in which it has to put the data through the X-server protocol on the display server and then get it back. And communicating over the X-server is really slow on Linux. So the problem was not as strong in Mac and Windows, but the problem is, even considering that and having only a few getImageData as we have here, well, putImageData in itself is really slow too, and it's a known bug. Now you know the number of the bug, and the problem is it's not obvious what should be done to make it faster. They just know that it's too slow for now. Anyway, so considering that, what options do we have instead of using getImageData to store data? Well, I thought about using data URLs, which is something you can do on canvases. You can call this method toDataURL, and then you get an actual URL that you can use in a browser in the omnibar there, which looks like this data, in this case image/png, and then a comma, and then some data about the image. And as a result, you can use it as the source of an image that you create right there, and that image gets loaded with the data. So this is a bit contrived because you should wait for the image onload event of that image, waiting for the image to be loaded. Otherwise, you have some issues. But it's basically as simple as that. You store the image, and then you paint the image through the drawImage API onto the context, and the image gets drawn, and the rectangles get drawn, and that's the purpose of it. But that API toDataURL is both slow in Firefox and in Chrome, so even though in both cases drag and drop was really smooth, every time we hit a rectangle that was not cached, well, the cost was huge. So I tried another property of Canvas, which is toBlob. You get a blob of data, and you can convert that blob of data into an image. So it is very, very similar to the toData URL that you have here. The only difference is that it's completely asynchronous. Theoretically, the browser can do it in the background without disrupting the drag and drop. And when it's done drawing, it can start putting the pixels on the screen. It turns out that Firefox on its side doesn't do it in the background up until a day ago, and on Chrome's side they haven't implemented toBlob yet, so no dice. And the last thing I tried, which is the one I'm going to go with, which is really efficient and really good, is to use canvases as a storage medium. So those canvases are not actually in the DOM in the object model of the page. I create them right here. I set the width and the height, and then I pen the pixels in them. And it turns out you can use canvas as if it was an image in the drawImage function call, as described here. Check the usability of the image argument, and by that they mean be sure that you can use it as a means to draw something, and you can, because canvas image source can be either an image, a video, or a canvas. The last two are not implemented yet in browsers. And this is what I'm using right now. It is really smooth in Firefox. You even don't hit any performance issue when you hit a rectangle that hasn't been cached. It's great. So that's what I'm going with. And if you hit issues with getImageData, as I believe a lot of people do, try to find a solution using canvases, because that works really well. So that's what I did lately. I hope you like it. Thanks very much for watching, and see you next time.